Bismillahirrahmanirrahim. Assalamu alaikum everyone. Today we're going to learn lesson number 35. It is a new part of pre-calculus, and we move on from Bismillah from trigonometry, and we start with a topic that is generally considered advanced algebra 2. All right. If you're going to be continuing, which many of you are, inshallah, with calculus 2, you're going to see these topics much more. If you're not going to go to calculus 2, then this is pretty much it. You're going to see these topics and probably never again. There is one little bit I'd like to mention, though, is this topic does show up every single year as a couple of questions on the ACT. All right. So let's go ahead and get started. Today we're going to learn lesson 35. It's called sequences. It's a way of thinking as well. All right, and I'll be sharing that with you as we go along. First and foremost, sequences and series, there's a whole lot of formulas that you need to be concerned about, and they're very different looking. So you can find these, as you know, in the important concepts that I have published on the website. Just scroll down and you'll find something that says lesson 35, lesson 36, sequences and series. All right. And as we go through this lesson, inshallah, I'll try to refer back to these formulas, all right? And because we will be needing them anyway, so we'll talk about them as we go along. All right, so the first thing that I want you guys to learn is called a factorial, all right? So most students, when they first see this, they're like, oh, why is there an exclamation mark next to a number, right? But it's a little bit more than that. So let's take the number 10, all right? Number 10 says find 9 factorial. So the exclamation mark, first off, that's called a factorial. And what that really stands for is you're supposed to take the number 9 and then take the number that's 1 less than it, and then take the number that's 1 less than it. And like this, you basically take all of these numbers and you keep multiplying them. And if you are thinking, how far does this go? This goes up until you end, which is at 1. All right, it does not go into the negative realm. And when you find 9 factorial, that is basically the answer to that question. Now, yes, technically speaking, what that really means is with the axis of a calculator, you really have to do 9 times 8 times 7, and that continues onwards. However, I'd like to take a moment and tell you that there is a button on your calculator. Most people forget this, but again, if you can remember, that will help you. So you basically write the number 9 in, of course. Then you go to math. You go to PRB. PRB stands for probability. And then you go all the way to option number 4. And there you go. That's your exclamation mark. And so the answer is 362,880. And so if you were to find 9 factorial, that's what that would be. All right. If you're wondering what exactly is, the whole point of doing something like that, you may remember from middle school that your teacher may have said that you have a 4-digit passcode. All right. Before, I think you guys probably still remember, when Apple came out, it had a 4-digit passcode. Now it does it 6 digits, but this will get the point across. So now I want you to think to yourself, what kinds of digits are you allowed to put into a passcode? I don't think 0 is, 0 is part of it. So you can put anywhere between 0 to 9 in there, right? So how many options is that? That's actually 10 options, right? That's 10 options. And then let's suppose I told you that, listen, you're not allowed to use the number that you use in this first box ever again, right? So after you use a certain number, let's suppose you use the number 5, you can't use the number 5 again. So what I'm trying to explain to you is then after that, you don't have 10 options, you have 9 options. You get it? And then over here, you'll have 1 lesser option, so 8 options. Then that over there will be only 7 options to go, right? So what exactly does 9 factorial mean? 9 factorial means you keep going all the way until the end, right? You just continue to fill out these boxes. Like you imagine you had more boxes. And that's one of the uses of factorials, in case you were wondering, like, why exactly do we even have something like that? Okay, now let's try something different. Let's take number 14. And number 14 says 5 factorial multiplied by 8 factorial divided by 3 factorial. Now here's things that it's not. Don't multiply the 5 and the 8 and say, oh, wow, this is 40 factorial. That's not how factorials work. It's a very different language in Bismillah, in mathematics. So what you're actually supposed to do, what this actually stands for is this. You got to write out 5, all right, like this over here. 5, 4, 3, 2, 1, right? Remember they're being multiplied. And then you got to write out 8. So as much time as that takes, that's okay because we're learning this. So 4, 3, 2, and 1. And then in the denominator, you have to have 3, 2, and 1. All right, so thankfully, if you understand how a calculator processes things, you'll realize that, I could just literally put this all in a calculator and I'll get the job done. So 5 factorial, all right, so 5 like that, multiplied by 8 factorial, so multiplied by 8, and then again, we go down that route and pick the factorial option like this. And then whatever you get out of that, see that huge number, now you're going to divide that by 3 factorial. And so 3 factorial is 3 times 2 times 1. You could just say it's 6 and divide by 6, or you could just be consistent and write it in. So the answer to this is 806,400. All right. There's one little note I'd like to make for you, and I'm not sure if this number 14 gets that point across too well. So I'm going to backtrack a little bit. I'm going to go to number 12 just to show you something that you can do this without using a calculator, right? So think about it. If somebody tells you 12 factorial over 10 factorial, right? Technically speaking, this is 12 times 11 times 10, but for some reason, for whatever reason, I decide to stop at 10 factorial. Okay, just pretend that I just decided to stop, right? Think about it. In the bottom, you also have 10 factorial. So technically speaking, you would have written both of these as 10 times 9 times 8 times 7, blah, 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 right? So why not just take care of that right away, cancel that factorial and the one on the top and the bottom, so you actually are left over with something that says 12 times 11. And 12 times 11, I believe, is 132. We'll see how I did that. All right, so that's objective number 1 for you to be able to evaluate a factorial. All right, let's go to objective number 2, inshallah. This is really where this lesson starts to take off. So now what we're going to do is we're going to talk about something. These terminologies are very new. Okay, so you just learned about factorials. Now we learn about 2 things. Number 1, we're going to be defining something called a term. Okay, what's a term exactly? And another one is sequence. Okay, what's a sequence? All right. So the best way I have found to explain this to students is just to try an example, and it makes a whole lot more sense that way, right? So I'm going to take number 20. All right, I'm going to try to stick to just doing one. So number 20, first off, notice that it's got this really interesting looking bracket around it. Okay, so it says D sub n. That's read D sub n. And then it gives you a bigger parenthesis, and that says negative 1 to the power of n minus 1 multiplied by n over 2n minus 1. Okay? All right. Now, this right here is called an nth term sequence. And some folks will just call it the nth term. Okay, it's called an nth term sequence. And you will see in a moment what it does. So the question says, can you write down the first 5 terms of each sequence? Okay, so we're going to write down the first 5 terms that we get by using this sequence over here. So if you'd like to make a chart, it may help you. All right, you can say n is equal to 1, n is equal to 2, n is equal to 3, 4, and we'll put 5. Actually, you know what? It's probably better to put it here. So n is equal to 5. All right. And I'll do a few of these for you, or maybe all of them. We'll see, inshallah. So the first thing that you do is you say when n is equal to 1, then the sequence becomes d sub 1. When n is equal to 2, the sequence becomes d sub 2. And if you're wondering how are you making that connection, if you look at the beginning of the problem, it says d sub n, and so when n is equal to a certain number, it becomes d sub that number. And that's why we call it the nth term sequence, right? And when you plug in the n value, then it becomes perhaps the second term sequence. It just depends on what term we're talking about. Okay, now what we're going to do is we're going to plug into the formula. So initially this, you don't want to take a backseat to this and be like, well, this is quite easy. It actually is one of the most difficult topics in Calculus BC, inshallah, when you get there. So 1 minus 1, 1 over 2 times 1 minus 1, like that, all right? Now generally you're not allowed a calculator for this, so just kind of keep that in mind. Obviously I can't keep track, but I'm just letting you know. So on the top there it says 1 minus 1, which is going to give you a 0, and ask yourself what's anything to the power of 0. So this piece right here is going to give us a 1, all right? And then the rest of it becomes 1 over 2 minus 1, which becomes 1 over 1, and so the final answer to the first one is the number 1. Okay? All right, now let's put in the next term over here. So we have negative 1 to the power of n minus 1, so 2 minus 1, and then that's multiplied by 2 over 2 times 2 minus 1. So notice that as the n value is changing, it's just like plugging into a formula. As that n value changes, you just go ahead and you keep changing that piece right there, right? And so again, just sort of simplify this. That piece right there is going to give us negative 1 to the power of 1, which is simply negative 1. Then all of this stuff over here is going to give us 2 divided by 4 minus 1, which is 2 divided by 3. And with that negative sign out front, it'll simply become negative 2 over 3. All right? And then you go to the next one. All right? So you basically just continue this pattern. And yes, it is a pattern. At some point, you'll come to realize that. And I'm only doing this for you, the whole thing, so that you can start to see how I'm determining this pattern here. So now this next one, notice how this is simply going to become negative 1 squared. And negative 1 squared it goes back to 1 again. So now it's going to become a positive. And over here you'll have 3 over 6 minus 1, which is 3 over 5. So this is positive 3 over 5, right? Number 4, negative 1 to the power of 4 minus 1. It's quite repetitive, and that's the whole idea in the beginning, is just to get used to that repetition, because after some time the formulas, when they kick in, it gets kind of crazy, right? So negative 1 to the power of 4 minus 1 is going to give you negative 1 cubed, which is negative 1. Then over here you'll have 4 divided by 8 minus 1, so 4 divided by 7. And here is what we have, 4 divided by 7 with a negative sign out front. Now I tell you what, you are welcome to do that next question, all right? See where that would actually take you. But what I will tell you is more than likely the answer should be positive 5 over 8. All right? Sorry, not positive 5 over 8. Positive 5 over 9. Now, if you're wondering, how did you figure that part out? Okay, so watch carefully. I know that I started off with 1, right? The first term was a 1. Now, when we write out a sequence, so what I'm writing out here is the sequence. All right, I'm writing out the sequence. So as you write out a sequence, you basically, what you do is you'll separate them with commas, right? So I noticed that the first term was a 1. Then I noticed that the second term was negative 2/3. Then I noticed that the third term was 3/5. And then the next one after that was negative 4 over 7. And what I had used, what I made a conjecture about was I said, I think the next one is 5 over 9. Now, if you're wondering, how did you figure that part out? Well, I was looking at patterns. I noticed that the top one is 2, then it's 3, then it's 4, so I made a conjecture that the next one should be 5. Furthermore, if you want to fit the pieces in together, think of this one over here as 1 over 1, right? Then in that case, right, we start off with 1, 3, 5, 7, so I figured the next one in the denominator should be a 9. Okay, and finally, the one last thing to mention, notice how the first one was a positive, the next one was a negative, the next one was a positive, negative, so I made the conjecture that the next one should be positive. This right here, this process where it keeps going positive, then negative, then positive, then negative, then positive, that's called alternating. Okay, this is called alternating. And more specifically, we often call it an alternating sequence. All right, so you are welcome to try. The third objective in this lesson is quite challenging. And in this, what we're going to do is we're going to be kind of working backwards, is you're going to look at a pattern. Okay, you're going to look at a pattern, and then you're going to try to write down the nth term formula for that pattern. Okay, so that is a lot more difficult. It's just, it really upgrades in level of difficulty, where before we could look at a formula. All right, we had a formula to work with, and then we took the formula and we created a sequence. Now please realize that you're going back the other way. You're taking a sequence and you're making a formula out of it. Now this part right here, it's, listen, you'll find yourself writing things down and then scratching them out. So please be patient with yourself. It doesn't just come to you. It takes a little bit of intuition to do these things, all right? So I'll give you some strategies to help you start thinking about them. So one thing that you can do is be organized. Okay, so I'm going to be organized. I'm going to write down n is equal to 1. And when n is equal to 1, I have 1 over 1 times 2. Sorry, I didn't mention which one I was doing. I was doing number 28. All right. Then when n is equal to 2, I have 1 over 2 dot 3, or 2 times 3. When n is equal to 3, then I have 1 over 3 times 4. All right? And usually if you start saying it to yourself, right, you might initially sound kind of crazy, but it really helps to figure out what the pattern is. So what I'm saying here is when n is 1, the answer is 1 divided by 1 times 2. When n is 2, the answer is 1 divided by 2 times 3. When n is 3, that becomes 1 divided by 3 times 4. And when n is 4, it becomes 1 divided by 4 times 5. Making an nth term is all about, okay, what if n was equal to n? Then what would you write in this situation? All right? So here's how I see this problem. All right? I can say that that first one is 1 over 1 times 1 plus 1. Now initially you might say, I don't quite see it, and that's what most students will say in the beginning, but you get used to it. So let's try this next one. I'll say the next one is 1 over 2 times 2 plus 1. Then I can say that the next one is 1 over 3 times 3 plus 1. Then I can say the next one is 1 over 4 times 4 plus 1. See, as human beings, as we continue to look at something, we start to develop patterns as to what is happening here. So one thing you'll realize is the following, that when n is 1, the numbers that are impacted are out front and the number right here. When n is 2, the number that's impacted is the number out front and the number right over here. When n is 3, the number that's impacted is the number out front, and then, one second, let me get rid of this. So, oops, sorry. and then the number that's right over here. So that's the whole point of having an nth term formula. An nth term formula says, okay, if I give you any n, can you tell me what the answer should therefore be? And so what we're going to deduce is every single time what basically happens is that green highlighting implies that the n stands there and it's multiplied to n plus 1. Now having done this, you call this the nth term formula. So you can call it a sub n, and you don't need to make these parentheses around them, but if you do, that's cool. And so this formula right here, I was able to get it done by looking at it backwards, okay? And there is no one exact science to doing these, all right? It takes some time, but what I want you to notice is I put now in those same two highlighted spots, instead of numbers, I had to put Bismillah ends. But what was the intuitive part? The intuitive part was to go from here to here, right? To think of it that way. That's not something I can necessarily teach you. It just takes a bit of practice to be like, oh, okay, so this is the pattern. Now you're an intelligent class, and if you practice these enough, I know that you can do it. In fact, to me, they're like mind puzzles. I actually enjoy them a lot because they do put my mind to the test. All right. So let's try the next one. Again, I'm trying to do all the evens for you guys. So n is equal to 1. N is equal to 2, n is equal to 3, and n is equal to 4. All right. All right. When n is equal to 1, I have 2/3. All right. Looking at one thing, there's nobody in the world who can look at one term and say, oh yeah, I know the pattern. All right. They're just guessing. They don't actually know the pattern. All right. Now n is equal to 2 is somehow 4/9. But here's what I'm going to do. I'm going to start to form some kind of a pattern. I'm going to say, isn't that technically 2 squared over 3 squared? All right. Let's keep moving. The next one says 8/27. And I'm staring at 8/27 going like, God, what is that? What if I called it 2 cubed over 3 cubed? You see where I'm going with these, right? Now let's look at the next one, 16/81. What if I call it 2 to the power of 4 over 3 to the power of 4? Now I'm going to backtrack. To that first term. By the way, I started all wrong here. In that last one, I kind of started with the first term, and you're probably wondering, like, what made you think that? No, actually, the first term, you can leave it. Honestly, you can leave it and come back to it at the end. Like, see, like, okay, what fits into the pattern, right? Does it fit or does it not, sort of a thing, right? So I'm going to come back to this. I'm going to say, well, technically, isn't this 2 to the power of 1, 3 to the power of 1? Now, here goes the highlighting. So when n is 1, the 1s show up right here. When n is 2, the 2s show up right here. When n is 3, you get 3s. And I think you catch on to the pattern. So as soon as you develop the idea of the pattern, that does feel good. You're like, okay, I got this figured out, right? I've solved the riddle. So when n is equal to n, right? N is not equal to a number anymore. What do you say is the nth term formula? You would say basically the pattern is 2 to the power of n divided by 3 to the power of n. That n keeps changing based on the term that I have. Look at the highlighting, and then it'll make a lot more sense where I got that intuition to make those over there n's, right? So it's tough, right? It takes some time, but inshallah you will get used to it. All right, let me show you guys a few more flavors of writing down patterns. So we continue in the same vein. N is equal to 1. I get a 1. N is equal to 2. Oops, sorry. That's not. N is equal to 1. I end up with 1. N is equal to 2. I end up with 1.5. Right? So start thinking, how are they doing that? N is equal to 3. I end up with 3. Now, how exactly in the world can a 1 become a half and then become a 3? That doesn't look like there's a pattern, right? But it just, it takes some time to try to figure this out. At 4, it becomes 1/4. At 5, it becomes 5. At 6, it becomes 1/6, right? Listen to my words here. At 7, it just becomes 7. And at 8, it becomes 1/8. Come on, now let's think about where is this pattern going, right? With a 1, we had a 1. With a 2, we had a 1 over 2. With a 3, we had a 3. With a 4, we had a 1 over 4. So if you keep following this pattern that I'm saying to you, you got to realize that this is a very different kind of a pattern they're talking about, right? There is a relationship, and I remember this one really got our students last year. The relationship is the following, right? And you may write it like this. You can say, look, n is going to equal, all right? N is going to equal the number n, all right? As long as n is odd. And if you don't want to write it like that, you can just say, well, you know what? I have an answer of n as long as n is odd. All right, you'll see where this is going in just a moment. Then we can say that I get an answer of 1 over n every time n is even. So yeah, it's like a piecewise function sort of a thing, if you want to call it that, even though we don't call these functions. And there you go. That is our nth term formula. Give me a value of n, and I'll look at that n, and if it's an odd number, I'll say that's just going to be the value itself. So if you told me 13, I'd be like, well, 13 is the answer because 13 is an odd number. Then if you told me 14, I'd be like, well, 14 is an even number, so I'm going to tell you the answer is 1 over 14, right? So that one's been a tough one for students in the past, and there you have it. Number 34, feel free to pause this, right? And try it by yourself and be like, okay, let me see if I can figure out this pattern, right? So you got n is equal to 1 is a 2. N is equal to 2 is a negative 4, right? So think about how can you possibly go from a positive number to a negative number, right? Think about it. What do you need to multiply by? Forget about the 2's and the 4's. What would you need to multiply something by to go from a positive to a negative, right? N is equal to 3 all of a sudden becomes positive again, right? So it starts to become a little bit more clear how we're proceeding with this. It keeps going positive, negative, and then positive again. But there's more to it. If you do enough of the first questions that we tried, if you do enough of these, you'll realize that every time you have a term that looks like this right here, right? This is the one that I did for you, number 20. Or that right there. Or this over here. Every time you have one of these, what it does is it causes the signs to alternate. It goes positive, negative, so on and so forth. So this sequence that we're looking at is an alternating sequence. Now, initially you'll be like, oh my God, how do you even figure that part out? After some time, you get that pattern and you're like, okay, this is an alternating sequence because I noticed that that second number is negative, the fourth number is negative, whereas the first, the third, and the fifth terms are all positive, right? So you keep going positive, negative, positive, negative. So one thing I can tell you is this is going to have some such term like this. It's probably going to have this on there, or it's going to have that on there, or it's going to have one of these on there. It's one of them, right? And feel free to do that part in the end, okay? You don't have to do that in the beginning. You could do that in the end if you like, all right? Because that's a little bit tricky. Basically, you got to put one of these pieces out front, which will cause the sign to keep switching, right? But let's talk about the numbers, right? Let's talk about the numbers themselves. Well, I know that 2, right? I told you before, I'm not going to start with the first term. So let me start with the second term. I could say that negative 4 is the same thing as negative 2 times 2. I could say that 6 is the same thing as 2 times 3. I could say that negative 8 is the same thing as negative 2 times 4. I could say that 10 is 2 times 5. Now try to look at the pattern. What did I just do here? Try to go all the way back to the first term and be like, well, isn't technically 2 the same thing as 2 times 1? Now let's study these patterns. In case you didn't see it, that's perfectly fine. It takes a while. So 1 and 1, 2 and 2, 3 and 3. And so you keep going in this pattern and you will begin to realize, okay, at least I got something. Is when he says n is equal to n, I know that for sure there's going to be a 2 and it's going to multiply to the n. You see how I did that, right? So you know it's basically 2n. But what about this negative sign? It keeps switching. So that one's a little bit tricky. Like, how exactly do I get that to work in my favor? So the one that I'm going to choose here, the one that I'm going to work with is, let's try choice number 1. Okay, let's try choice number 1. Let's see if this works or not. Pretend it's like fitting parts. If you're into cars and stuff, just pretend like it's fitting parts. And you're like, I wonder if this part will fit or not, right? So let's take this first one right here and let's ask ourselves, can this work if I were to call it -1 to the power of 1, 2 times 1? Is that answer still the same as 2? If it's not the same thing as 2, then that first part that we picked does not work. All right, so you'll realize very quickly that -1 to the power of n, and in this case n is 1, so -1 to the power of 1 is -1, times 2 gives you -2, but I needed it to be +2, so that first part doesn't fit, and so I'm going to throw that out and be like, nah, that doesn't work for me. Okay, that doesn't work. I gotta think of something different, right? So let's try option number 2. All right, let's try option number 2. Option number 2 says try fitting a try fitting a -1 to the power n plus 1 out front. So let's see if that will work. So if we were to fit a -1 to the power n plus 1, that would become -1 to the power of 1 plus 1, and that's 2 times 1. Now ask yourself, does the answer to this really give you 2? And it does, right? Because -1 squared is 1, times 2 is 2, and that fits. But don't just stop there. Make sure that all of them are fitting in, right? So at some point you do develop the pattern. So now if you make this -1, 2 plus 1, right? Because everything here is n plus 1, times 2 times 2, again ask yourself, does that give me -4 as an answer? And it does, right? I had students who they told me like maybe half an hour trying to figure out the secret to this. And then they came into class and we figured it out together. You just kind of talk through it. It makes a lot more sense. So eventually I will post the solutions to the homework for this, and inshallah you'll figure it out as well. But there you go. That was the pattern that we were working with. So when we get to the end here, right, when we get to the end, which is the nth term, I'm going to say that the part that fits is -1 to the power n plus 1. And so this is the nth term formula right there. I'll repeat, this is not easy, okay? It takes time and it takes patience. So please don't give up on it. Inshallah, you'll figure it out. If you're wondering, can other parts have fit into this? By all means, I recommend for you to try this. See if -1 to the power n minus 1 is a part that'll fit or not, right? Because sometimes you can have multiple parts that can fit into the same spot. So give it a shot and see where that actually goes for you, okay? All right, now the next objective, which I think is objective number 4, but then again I've kind of lost count here, is surprisingly a lot easier. Okay, the third objective is always the hardest objective every year, right? And I've even had classes where they tried and they tried and they tried and they're like, yeah, we give up, we're not doing this one anymore, right? So inshallah your class will not be that way and you'll figure it out. Okay. Now, this right here, I don't need to do too many problems about. This is called defining a sequence recursively, right? If you know what a recursive is, a recursive, it refers to something of the past, right? Like, for instance, I could say that I won't tell you that how old I am, but I could tell you that I am 1 year older than I was last year, right? And you might think to yourself, well, then what were you last year? And then I tell you, well, last year I was 1 year older than I was the year before that. And you'll be like, great, now I'm stuck because now I don't really know where you're going with this, right? So that's the idea. Is recursive, it refers to the one that was before it, okay? To tell you the new, it talks about something that was previous to it, all right? So I'm going to take, let me look for a good question to try here. We'll try number, Bismillah, let's try number 42. Okay, so we'll try number 42 together. We'll try number 44. And I think that number 46 right here might be helpful to also try. Okay? All right, so let's start with number 42. Number 42 says that the first term of a sequence is -2. Right? So now we're telling you what the first term of the sequence is, right? What it starts with. And the next thing they tell you is the nth term sequence, right? Or the nth term formula, sometimes we call it, n plus 3 a sub n minus 1. Right? Now initially this looks kind of confusing and you're like, wait, how is this easier? But you'll find that this is a whole lot easier than that last objective. And we need to write down the first 5 terms, right? We got to write down the first 5 terms. So we already have the first term. The first term is -2. We're done with that. So we're like, okay, I know a sub 1. The second term would be a sub 2. If you don't know how to fit this pattern in, so it's a sub 1, a sub 2, a sub 3, and so on and so forth. So we have to keep going till we get to a sub 5, and we'll have 5 terms, right? So a sub 2 is going to become 2 plus 3 times a sub 2 minus 1. Now, how did I do that? The formula says if you need a next term, plug that term number right here and plug that term number right here. That's all that stands for. So when we did that, here's what it looks like. It looks like 2 plus 3 a sub 1, right? Because what is 2 minus 1? 2 minus 1 is 1, so it looks like 3a sub 1. So you might look at it going like, wait, where does that do for me? See, this is what we mean by recursive. We're saying that if you want the second term, you need to add the number 2 to 3 times the first term, because a sub 1 stands for the first term, so that's what makes it recursive. It's the new term refers back to the old term. So to get the old term, it was given to you. That's why they started you off with that. And because you already know that a sub 1 is -2, then you basically just plug in 2 plus 3 times -2. And that right there, first do the multiplication. So 3 times -2 is -6. And add that to the 2. So you end up with -4. So we now have the first 2 terms. The first term was a -2. The next term is a -4, like that. All right? Let's keep moving because we need all 5 of the terms. So I'm going to go to a sub 3. Once again, using the highlighted parts of that formula, when a sub 3 happens, when that 3 happens, you're going to take the number 3, again using this formula right here, plus 3 times a sub 3 minus 1, right? And so that becomes 2, sorry, I apologize, not 2. It becomes 3 plus 3 times a sub 2. And why? It's because 3 minus 1 gives you 2, so that becomes a sub 2. And again, it's recursive. It's referring back to something. I don't know why I keep writing 2, but it's recursive. It's referring back to something that you already did, and you already found out what a sub 2 is. You found out that a sub 2 is -4. So you bring that -4 forward and you plug it in. And now you will have your a sub 3. And your a sub 3 is going to be 3 times -4, which is -12. And add 3 to it. So you end up with -9. So now you have your next term like that over there. Okay? And because it's repetitive, I will allow you to do the rest by yourself. But I'm sure that you have quite quickly figured out this pattern, right? Let's try a couple more. Okay, so let's try number 44 here. Okay, number 44. Again, we want to go to the first 5 terms, but I want to kind of stick to a few, and inshallah, we'll see how that goes. So number 44 says, all right, we'll give you this hint. The first term is -1. Okay, very good. So I already have one piece of the answer. I know the first term is -1, right? Then they give you a second hint. They say the second term is +1. Well, that was easy. So now I know the second term, right? Remember, we need to get to the first 5 terms. Then it gives you this really weird looking formula. It says, if you want the next term, here is the clue. Take a sub n minus 2 and add it to n multiplied by a sub n minus 1. Now, just looking at it, I know that it looks super confusing, but it's not. It really isn't. You just start with writing down the terms that you have, and you continue that pattern. So we already have 1. We already have 2. So where should we start? We should start with 3, right? Now, what does the formula say? It says whatever n is, it's going to show up here, here, and over here. All right, so let's go ahead and start. We'll have a sub 3 minus 2 added to 3 times 3 minus 1, right? And what's that going to look like? That's going to look like a sub 1 plus 3 times a sub 2. And that's why it's not a surprise that they gave us a sub 1 and they gave us a sub 2, because we can't find a sub 3 until and unless we don't have a sub 1 and we have a sub 2. So now that we have those, right, we can find out what a sub 3 is. And so a sub 3 is actually equal to -1 added to 3 times 1, which is simply 3. So a sub 3 is going to be 2. All right, so we'll go up here and we'll write it into our box. Okay, let's do another one of these, right? So a sub 4. What's a sub 4 going to look like? A sub 4 is going to be a 4 minus 2 plus 4 times 4 minus 1. And now we're going to have a sub 2 plus 4 times a sub 3. And again, it makes a lot of sense that we have those previous 2 terms. Now go back and find what a sub 2 is. A sub 2 is a +1. It's right here. And what is a sub 3? A sub 3 is a 2, right? We found that in the previous problem, right? We found that previous problem. That's what makes it so recursive. So just put the pieces together. 1 plus 4 times 2. So 4 times 2, do that first. That's 8. Add 1 to it, and you end up with 9. So there you go. The fourth term is going to be 9. And like this, you just continue that pattern. You just continue that pattern. You can find a sub 5 in the same way. Just go a sub 5 minus 2 plus 5 times a sub 5 minus 1, and just continue with that. Number 46, let's just do this one. A sub 1 is equal to a, all right? Number 46, a sub n is equal to r multiplied by a sub n minus 1. So here, they just use like an r. All right, you'll find out later what that r stands for. Just for now, our job is to still just write down the first 5 terms. So this should seem relatively straightforward. The r is just going to remain an r, by the way, right? So let's go to the next term, which is going to be a sub 2. So a sub 2 will become r multiplied by a sub 2 minus 1, which becomes r multiplied by a sub 1, which becomes r times a, so you could call it ar. All right, now let's go to the next one, a sub 3. A sub 3 is r times a sub 3 minus 1, which is r times a sub 2. And a sub 2, we just found it, a sub 2 was ar. So you're multiplying r and ar, and you end up with ar squared. All right, a sub 4. R times a sub 4 minus 1 gives you r times a sub 3. And we just found a sub 3, so r times a sub 3 is going to give you ar cubed. And the thing is, because these are all patterns, just as you continue them, you'll start to realize what the answers are. So The first term is A, they told us that. The next one is AR. The next one is AR squared. The next one is AR cubed. Guess what? If you were to just give it a guess, you'd be like, yeah, the next one's going to be AR to the power of 4. All right, so the last question, sorry, that we want to try is a application question. And it really helps you to understand like how, where does this stuff apply? It's actually used a lot in the financial sector, a lot, okay? Here we talk about populations. So it says a pond currently has 2,000 trout in it. Okay, so there's 2,000 trout in it. And let me just pause here, right? Well, let's speak with some substance. So when they say there's 2,000 trout in this pond, notice how right over here it says P sub 0 equals 2,000. So get used to that. Is when they say P sub 0 equals 2,000, I usually tell my students, think of that as like an initial amount that you have. All right. Now, it says a fish hatchery decides to add an additional 20 trout each month. So they're putting 20 trout more into this pond each month. In addition, it is known that the trout population is growing 3% per month. So the size of the population after n months is given by a recursively defined sequence, and that sequence is right over here. So it's literally using the same thing that I just taught you in that previous example. So this should not take too long. And you're just going to be applying that to a real life situation. So P sub n is equal to 1.03 P sub n minus 1 plus 20. Now let's speak in terms of like, what do these things actually stand for? We notice in that last example that n minus 2 meant something that was 2 terms before it, right? So 3 minus 2, 4 minus 2, 5 minus 2. So whatever term you had, which was a 5, this was going to refer to 2 terms before it. In that same case, n minus 1 means the term that was right before it, right? So over here, when it says P sub n minus 1, here's how I understand it right away, right? I understand that what they're really saying is if you want to find out the population of the trout this month, all you need to do is take 1.03 and multiply it to the amount of trout in the previous month and add 20 to that amount, and you'll be done with it. Okay, so that's really how I read these. And so let's go ahead and read the question. It says, how many trout are in the pond after 2 months, right? So in other words, what is P sub 2? It clarifies for you. So let's figure this out. If we need P sub 2, P sub 2 will be 1.03 P sub 2 minus 1 plus 20, which becomes 1.03 P sub 1 plus 20. And now we have a problem. And the problem is this. If you want to find out how much you have after 2 months, you can't find that out until unless you know how much you had after 1 month. So what does that tell you, right? That tells you that you have to keep going, spiraling back more. So now you're like, wait, I need to find P sub 1, right? So in real life, this is how it would work. You'd be like, okay, 1.03 P sub 1 minus 1 plus 20 is the same thing as 1.03 P sub 0 plus 20. And now we're in business, because if you think about this initial condition they told us, they said P sub 0 is 2,000. And I just got stuck with something that says P sub 0. So you fit all the pieces of the puzzle together. You're like, oh, okay, so this is 1.03 times 2,000, add 20, and that'll give me the population of trout after that first month. All right, so let's take a moment. Let's turn this calculator back on, and let's do 1.03 multiplied by 2,000, right? And then inshallah we will add 20 to it. All right, so you end up with 2,080 trout at the end of 1 month. right? So you know that this is 2080. And now that you know that this is 2080, well, where does that take you? With you knowing that this first month now is 2080, you can take it back and plug in for that formula, and that's why I left that little bit of space there. So you can say 1.03 times 2080, add 20. So even though we're going in a forward fashion, to find the next number, you need to know the previous number, right? So that's why we're writing kind of from the finished result back the other way. And so now when you type this in, so we can just take that old input and just change that 2000 to a 2080. And when you do that, you end up with 2,162 trout. All right, so you end up with P sub 2 is equal to 2,162 trout. So you just ignore that last piece that was 0.2 or something like that. Obviously, that would just be a dead trout. Right? It's just a model that we're working with anyway. All right. So thank you so much for listening, and good luck on doing the homework, inshallah. And assalamu alaikum. And so that kind of does it for the lesson.